All right. Headphones, 1 second. I plugged them in before, so we'll. Okay. It's stuck if it's focused. It hasn't been focused. Good morning, Paul. Nice to see you, my friend. I think we are ready. I've got this going. Yes, looks good. I can. Can I? All right. So, welcome. Good morning. Happy Saturday. Happy New Year. If you did not see the stream last week or haven't heard enough Happy New Year's yet, so it doesn't fall off. If you are new and don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. I stream about this time each week, Saturday mornings, 10 a.m. Central Time. We're running a few minutes late today, but right around this time, I usually stream work on CircuitPython something or other. Sometimes it's CircuitPython projects, sometimes it's libraries, sometimes it's infrastructure, sometimes it's just a wild, crazy-brained idea I have for fun. Just kind of depends on what is going on week to week and what I feel like. If you don't know what CircuitPython is, you'll learn more about it at the main website here, circuitpython.org. It is basically a version of Python that can run on tiny computers called microcontrollers. And when you use CircuitPython with these devices, the way it works is you usually will plug it into your computer with a USB cable. It shows up like a thumb drive. You can edit a Python code file, a .py file, which is just text, on that thumb drive. When you save it, the microcontroller, the computer that is in the chips here, will actually interpret and execute the CircuitPython code. And then your code can interface with other bits and bobs and pieces of hardware that are connected. So you can connect up RGB lights and speakers and screens and buttons and levers and sensors and all kinds of other things. But CircuitPython is the core project that runs on the microcontroller that I typically work on. There are 623 different devices here that support CircuitPython, and just to note, there are other ways you can program these microcontrollers as well. CircuitPython is not the only way, it's just the one that I tend to work on the stream here. Huge thanks, as always, goes out to Adafruit for making CircuitPython possible. They pay a team of folks, including myself, who work on the project. And that is really cool of them. All the code is published in the open source with open source licenses, largely MIT, but there is a mix of some others in there as well. So they pay, literally pay a team of developers to work on code that gets published as open source, which is super cool, super commendable. If you would like to help support them and CircuitPython, one of the easiest ways to do it is by purchasing hardware from their website, adafruit.com. You can get microcontrollers, you can get all sorts of bits and bobs to connect to your microcontrollers to make neat projects. And if you're looking for inspiration, you can click over to Learn, where there are thousands of documented projects and tutorials that you can either build outright, follow along with the instructions, or you can, take the instructions, make it your own, change out some parts, do it differently, that sort of thing. Just get inspiration from it. So all of that is there on their website, adafruit.com. And again, thanks to them for making CircuitPython possible. And thanks to everyone who buys hardware from them so that they can continue to make CircuitPython possible. So today I have hooked up, oh right, I'm not using the camera in the browser anymore. That's going to take a minute to get used to. So this is like bleeding out the brightness because of the super white screen. Let's do that little hack for now. So I have this new project which I'm working on, which is a talking multimeter. I have been working on a 3D printed case the last couple of days. I have some proof of concept code, and today we are going to work on fleshing out a bit of the UI, as well as just bringing up this new device which I put it in. So this is basically what I kind of envision for the final version of this project. You can see it's in a little thick looking box there. Almost got a Game Boy vibe going with the gray filament that I printed it in. And it is super easy constructed. We'll unplug the USB, which there's a hole for. It's just a mount plate with a feather TFT, rather a TFT feather wing, 2.4 inch there, a prop maker feather plugged into that, one of those 4 ohm, 3 watt, sort of like cheapo, $5, $6, something like that is I think what those are, speakers. And then I have a just panel mount push button, although that's not hooked up just yet. And then I have a mysterious hole in the front of it where the wires run out. And those are the probe wires for the multimeter. And it does have 3 instead of 2. Usually on a multimeter you would see 2. In this case, I have fed out 3 wires, power, ground, and the signal wire, which is white. So red is 3.5 volts power, the same power as the feather. White is the signal line, and then black, of course, is ground. And that is necessary for doing some different types of circuits with resistors. So the very, very, very first thing I need to do is actually put CircuitPython on this, because I will substitute this out and I will slide in this bird's nest of the first version, the proof of concept version of this, which is more or less sort of the same-ish thing. It's not the exact same. The screen is different. This is a Featherwing OLED something. It's not touch. It's a little bit different display. This is a TLV DAC, so it's a different DAC than what the prop maker has, but like functionally each part is represented here. It's got the speaker, it's got the DAC, it's got a button, and it's got wires in there somewhere that hook up to the analog input pin so that it can read voltages and stuff. So we're going to be moving from this bird's nest here, breadboard special, onto this one. And I have not really started even so much as loading CircuitPython on this device yet. So we'll do that first. I'll plug this in, and I'll just do it outside the box. And one thing that sort of hear that? One thing that sort of jump scared me when I plugged this in the first time is it's got preloaded demo with audio in it. And since I wired up the speaker and everything, it just played as soon as I powered it on the first time. And I was like, whoa. Let's go prop maker feather. Can grab CircuitPython for that. I'm usually just going with the betas. I figure if anyone is going to find something broken about it, it may as well be me or one of us who work on the project. And I assume this is a RP2340, so I'm guessing boot and reset should get us to the trusty F2 mode there. With the RP2 drive, we can just drag this one onto there. What's up, Gordy G, my friend? Nice to see you. This is a clever idea. Yeah, thank you. I appreciate it. It was, I can't claim full credit for the idea. It's actually rather old. There was like circa 2017, there was a post on the Arduino projects system. I'm not sure the name of it, but at that time, at least, there was a like community run post your project on Arduino, sort of Instructables type of thing is what it seems like to me. Someone posted it there, and then I think it got blogged or something like that. And we have this big list of like sort of wishful project ideas internally for Adafruit, and this one's been on there for a while. But I have been snagging some of them that seem interesting to me, and this one came by. The original project was a bit different, though. The one that inspired this, it was actually using a real multimeter that had like a UART output, had a way that you could get serial data out of it, so it would read the voltages to you, or ohms or whatever you're measuring. It would read those over serial, and then it was like a Raspberry Pi where it you plugged in that serial connection to the Pi, and then the Pi would talk the numbers for you. So it's a bit different. They didn't recreate the whole multimeter. They just added the talking box. I am going to have, I hesitate to call it all the way a multimeter because it does just have the wires hanging out. You sort of need to provide your own resistor divider, which I have been learning about the last couple of days. You need to provide your own like voltage divider made out of resistors in order to do most of the typical things that you do with a multimeter. I have not actually opened up a multimeter yet, but as of the last couple of days, learning about voltage dividers and resistors and how to put that together and what it does, I presume inside the multimeter, it has a couple of different voltage dividers, and when you turn the knob, you're selecting between different sizes or different ratios, rather. But I haven't actually opened one up to confirm. How many bits are in the ADC? Yeah, I don't know. I don't think it is gonna be like super duper accurate. I don't think this is the kind of thing you would want to use for like, I need a really, really precise measurement. Realistically, my assumption is the answer ultimately falls into whatever the Raspberry Pi Pico RP2040 in this case, whatever the RP2040 does by default in CircuitPython. Which I do not know off the top of my head. Analog in. Let's see, though. I am curious, because I did wonder about that the other day. Does this say anything about bits? 1 out of 6 matches. I don't know where it's actually at, though. Gonna be bitsies. Okay. No bits. Yeah, I don't know the answer off the top of my head, but basically the answer is my multimeter will have the same precision that analog in on an RP2040 under CircuitPython has. I don't know off the top of my head what that is, but that's what we're working with. And I do think it's not likely as precise as a real legit multimeter, but I don't know either. Okay, so first thing we could do is fix the camera by getting this white off of the screen because, like I showed with this before, this is like blowing out the brightness on the camera there. And this is a new camera for me, so I'm working with it. I don't know if there's a way I can adjust it manually just yet, but I can certainly take care of the screen. For that, we need to initialize the feather wing. We can just head to learn. We can go TFT featherwing. I believe it is this one right here, 2.4. I do have V2. I got the newer one for this project just because we're going to make a new guide out of it as well. We want to do it with the hardware that's available. And skip to here. This is mostly what I need. Copy this, put it here. I will change it. This is well, we could. Well, this is trying to do bitmap. That necessary. Do something without bitmaps. Is there? Wait, okay. Oh, that's fine. We can just get rid of the second half of this. I don't want that really splash. Okay, here's what we're gonna do. Get rid of this. We're gonna take this. Oh, this is interesting. It's making a group for every image. And cycling through them. It could use one group. It doesn't matter. I'm gonna take that. We're gonna rename it because I tend to like main group better than splash usually, unless it's like a splash screen, in which case splash makes sense to me. Main group, we're not gonna have index. We could keep the touch stuff. Eventually we're gonna get into touch, so we might as well keep that. Group, this could be main group. Touched state. Yeah, we could print it, and then we don't need to do anything else. Let's not worry about any of this. Yeah, do that. probably crashed because it doesn't have the libraries. So we can do circup, install, just do auto because it's going to need both of these two. Should find them from CodePy. And bus device also. Go, and it did not crash, and it is now on black instead of white, which fixes the camera. So, roundabout way to fix the camera, but that is what we got. So next, I think we should just try to get the proof of concept code and circuit running on it. I'm going to scooch this one out a little bit. I am actually going to plug in. It's not super see, but I'm going to plug in this one just for a minute. We can grab the code from it. I am going to push the button, which makes it actually plugged in for real instead of just pretend plugged in. There's the doodaloos we were expecting. This, open this. Code. So this has got a different display and everything in it. I think, though, that's fine. For now, what I'm going to do is just take this and go POC multimeter. We'll put talking multimeter. And I think that's all I really need from this one for now. So I'm actually just going to unplug it. That way I only have one device plugged in. Not notice, but I'll reload just so long. Okay, and then we can grab some of the stuff that we want from here. So a label to show the current readout. So at some point I'm going to build a more interesting UI than this, but for right now we just have a single text label that shows Control Tab instead of Alt Tab. For now, I just have a single label. So I'm thinking for the UI, the output on the display, I'm thinking a couple of buttons, like one button to select one button to select voltage mode, one button to select ohms, like resistor measuring mode, and then two more buttons, one for each of the resistors. You'll punch the resistor button, and then you'll type in the resistor values. Because that's the thing. You can use this with different, whatever voltage divider you want. You use it with that. Realistically, what you need to do is take into account what kind of voltages you're trying to measure. If you're trying to measure like 12 volts or less, which is probably what I'm going to document in the guide, my intention is to start with a 10K and a 3K, which should bring 12 volts down to right around 3 volts, which should let us measure it with the analog pin. Now, if you wanted to get up to 20 volts, you would need a different ratio of resistors. If you wanted to do, anything else, you would need to consider that. And then as far as measuring resistors in ohms mode, it does essentially require resistors that are kind of close to your target resistor. So if it's truly a mystery and you have no idea what the target resistor is, you need to probably either start big and then scale down or something like that to find out. To do a basic utility grade multimeter of 1.39s, you'd need at least 11 bits, but for 2 9s, you could get away with 8 bits, and I think most microcontrollers have 10 bits or occasionally 12. Nice. Okay, so we can... Yeah, I'm definitely in the, it's passable as can measure low voltage. Not super-duper precisely. It's mostly a guide about the talking and the pulling of everything together. And in this case, the 3D printed box, which I don't do a whole lot of 3D design and stuff. So this was actually kind of a fun one to build the box out with the faceplate and everything. This is all connected. It came out pretty nice. I'm real satisfied with how the box came out. But But yeah, it's very much a beginner's, fun project. Learn about multimeters and voltage dividers, even perhaps more than it is a functional multimeter. I mean, you could use it for basic stuff for sure, but it is as much as anything about the process of being able to peel back the curtain and see what is in a multimeter, essentially, even if not down to the same precision. Yeah, exactly right. CircuitPython, yeah, that's what we're trying to actually give people a new example, new idea. Let them take it on. And I mean, I'm sure there could be a microcontroller with a higher precision, or you could use some sort of external ADC that has a super high precision. In fact, I don't know about super high, but you could get higher, I'm sure, than the base microcontroller probably. All right, so that should give us a label in the center, and it should put it in the main group. It will start with nothing, though. So how about for now we just make it say the touch point? We could say like label text equals this f string and point x comma point y. Let's do that. That works. No display text. I'll just run auto again because I think I added a couple more things. Yeah, debouncer. Okay, it is there, but it's very small. Make that bigger. It is a resistive screen as well, so I do have to push a bit harder, and I have yet to peel the thing off yet because I'm like that, basically. I'll peel it off basically probably right before I start taking photos for the guide. Try to keep the screen nice. Able to fit 3. Eventually we may go down to 2, but go. Oh, 3,000. That's interesting. Okay, I think we're gonna have to. Okay, so zeros are down here. This is first number up, so this is X up, and then this must be Y up. Just reset because of a file operation. I usually turn auto reload off for that reason. My computer likes to just, I don't know what it's doing, but it triggers the auto reload basically. So then currently Y. So right now X and Y are swapped for one thing. Is there a thing I can do about that? I mean, I can certainly just account for it in the code, but it would also be nice if we could, if there's already like a Boolean or something I could set that will just do it automatically. Oh, not CircuitPython. Here, then here. Orientation or rotation. No. Invert. There it is. Invert? Is that what we want? Oh, swap XY. That sounds better, actually. I think that's what we want. What is that? The constructor, right? Yeah. Swap XY. Okay, so 0, 0, I presume, is still down here, but then this time, first number X, yeah, it gets bigger when we go this way, and then second number Y, it's bigger when we go that way. Let me. Okay. And we could maybe eventually do some kind of calibrating or something. Idford has external ADCs up to 24 bits. Wow. DigiKey has more. Yeah, so you could actually get quite a bit. Nice. Yeah, that'd be interesting to do like a come back later and do one with an external ADC and do it up as a more like not quite pro grade, but ready to be used as a multimeter more so than just a fun project. and maybe even be cool to wire up internal voltage dividers. I don't know about how the knob mechanism works exactly, but it might be cool to have those internally somehow, as well on like an advanced version of this project lineage. Okay, screen's working, touch is working. Let's get the speaker, which is going to be totally different code. So the screen and stuff I copied out of here. Eventually we'll copy some of the voltage reading and the formulas for that. But the speaker, I don't have code for, because this is actually my first prop maker feather. I've not used one before. Not even certain what DAC is on there. Whoops, we need this one. Volume. So I'm not worried about volume control so much right now, but this will have the setup for the DAC here, I think, right? Well, we don't. Yeah, I'm not gonna. Well, yeah, I don't know. I'm not gonna mess with a mixer just yet. We could do it later, ultimately to give us volume control, but right now I'm not gonna worry about it. Internal power? Probably need this. I'm guessing that's like a peripherals power pin. I think the fruit jam? Or if it's fruit jam actually or not. There is a device that has a internal pin like this that's essentially like a power cutoff for all the peripherals. And you can use it to save power if you are like trying to go to a sort of sleep mode type thing. You can turn off all the peripherals. And I'm guessing this might work the same way as that. You know what else I should have copied from the other one is the sound files. This 70 bits to actual conversion, resistance to voltage, current to voltage, etc. Circuit precision would be the bottleneck. Yeah, next, like, start gonna worry about the length of the wires and what material you're connecting with, all kinds of crazy. That pesky real world just throwing a wrench into the raw physics numbers. I think this, yeah, we want these sound files. So the talking is not super advanced. It's not using like, it's not rendering the speech live. I basically pre-rendered all the numbers and a point for it to say as well. And eventually I'll add like volts and ohms, and maybe something else. I don't know for sure. We could maybe do like, so one thing that isn't there right now. So like if it were reading the number 12, for instance, you know, if you did have it wired up to measure a 12-volt battery and you measured 12 volts on it, instead of saying 12, it would say 1, 2, you know, like 12.01 or whatever, right? Which gets the idea across, but is a bit awkward. I might go back and add, how big are these? I think we have a fair amount of room. I don't think these are that big. 24, well, okay, I mean, how big are all of them together? 300K. Okay, we could, if we doubled that, it would be 600K. And I think we have like 8 megs or something, actually, so. Yeah. 7 megs, pretty close. So we could do that. We could, I might add like 10, 11, 12, all the way up to 19, and then also add like 20, 30, 40, 50, up to like 90? Something. I don't know if I'll do hundreds. But then you could theoretically like play the 30 file and then play the 3 file or something, right? Like it would say 33 instead of 33. I don't know. I don't know for sure if I'll get that far, but now we will test this by just using one of them. This says to play the mixer. Ugh, maybe I'm gonna have to have the mixer. I think I can play the... I can play this one. And I think it will play the first time, so I'll run this.
7.
Okay, that is very loud, so we should use the mixer. I don't know if the microphone picked it up, but it's quite loud. But it did work, which is super cool. Great. Yeah. 22.5. Oh, 5. And then bitrate, they might all be different, honestly. I don't know. 352 for that one, which seems kind of random. I'm gonna check all of them, but I'll go with 352 for now. Oh, but that's, yeah. Is that right? Wait. Right? Bits per sample? Is that the same as bitrate? Oh, this was coming from the file. Okay, we don't need to hard code these. This is coming from this, which we opened from this. Presumably it's reading those values. Signed? I don't know. Whatever this default, I guess. I generated those with Piper ETS. Where's this one? Does this thing say signed at all? Oh no. Nothing about signs. Do a mixer? Could hear it say 7. Nice. Hopefully it wasn't too loud. Yeah, so we can set the volume, I think, with volume. Here we can set the volume with audio mixer. I've been here before. Deja vu. I was using audio mixer when I was playing with the synth stuff. Volume. Level. Volume level of a voice. And it's on a mixer voice. So you need to go... So in our case, we're using only one voice. So we're going to go voice 0. We're going to get a tuple from voice. We want the first object there, mixer voice. And on that, we can set level. And it's between 0 and 1. Synthia? I don't know, actually. Maybe this should just also be union. I think it can take a synthio, but it can also just take a float, right? So mixer voices, or is it voice or voices? Voice. Oh, that's weird that it's singular, but it gives you a tuple of all of them. So voice 0. Is it? Maybe it's not, I guess, because voice 0 kind of makes sense. Voice 0 dot level equals, I'll just start with that and see how loud that is.
7.
Still very loud. Let's try much lower.
7.
Okay, it's not affecting anything because I actually passed music here instead of mixer. Okay, that one, so now it's too quiet to hear. I still don't hear it. I don't think it's working. We give it a voice count of 1. So, but we never tied music to mixer. We set the sample rate, we set the bits. We put mixer to the audio output, the I2S, but nothing ties music to mixer. Need to do that, I think. A dot play. A is audio out. Okay, that's what we did. Oh, okay, there we go. We need to go voice 0 play music. I'm gonna set this back down. Mixer voice 0 play music. That'd actually be this, but I think I heard it. Maybe. Not hearing anything. Maybe this should go first?
7.
Okay, that should go first. Okay, there we go. That is much quieter. Perhaps even too quiet to come through. That is too quiet to come. Oop.
7.
That one I think did, based on OBS at least. But anyway, you don't need to hear it say 7 over and over. Okay. Audio's working, screen's working. Let's read a voltage and make it talk. This to make it easier to just play a file without do all of that stuff. Put it after. It says audio. Audio was the I2S out, which is I2S for us. Well, okay, so the thing is, back in this code, I was not using Mixer anyway, though. So realistically, we would want this to be on the Mixer instead of audio anyway. For now, I'm just going to hardcode this. Probably, honestly, be better to make a an argument there or something. All right, so we play the mixer up front, we set the volume up front, and then whenever we want to play a WAV file, we're going to call this function with the file name. We don't have to worry about the folder, it's going to take care of that. It gets the WAV file, it plays it on the voice, which is set by the volume. It waits for it to finish, and then it returns. So we get rid of this, that was our test one. Do the rest of the setup. Take word map, the starting loop, even though it wasn't. Nice touch there. Okay, and then I used, so we need these for now. Take these. We could do this test, actually. This test was kind of fun. This test. Eye action here. Do it after the display. I don't think it matters, but.
Point 14159.
So that's basically what it, same way it does the voltages. Although in that case, to the left of the decimal was a ones digit only, so it doesn't sound awkward. But like 12 as 1, 2 would sound a little awkward. Fine. Read resistance, we'll take that. I need both of these values actually, and I'm gonna need to change the known resistor as well. My intention is in fact to use a 10K, which is what the comment says. But in the circuit I was testing, I just grabbed 2 resistors out of the little drawer of a billion resistors that they get thrown into. And they happen to be very low values. It was like a 12 and a 23 or something. 22 maybe. But my intention for this circuit, and I pulled out some resistors as well before I got started. I pulled out a 10K and a 3K, and I also have a 4.7 to test on to make sure we can sort of accurately-ish measure it. Analog in, we don't have set up yet. But up here with more of the like pin stuff. I did plug it to a 3 on this feather, I'm pretty sure. We do want that. And then get voltage. Well, actually, this one. I'll probably move these around still. Button, yeah, we could. Well, no, I don't have the button wired up right now, actually. Yeah, I don't have the button wired up. I have some more buttons coming, actually. I grabbed, speaking of the drawer of random stuff, I grabbed a panel mount button out of my drawer of random buttons, which is near the drawer of random resistors. But it's not one that's in the shop, and it's got nasty legs that are soldered onto already anyway. And so because we're making a tutorial out of this, I also have buttons that are in the shop coming, and I believe they have a different diameter, so I think I'm gonna have to change the faceplate a little bit once they come. Now we're just gonna leave it without the button though, and we can just use the touchscreen actually for right now instead of the button. So this was doing button update, button fell, and then it was reading the voltage, and then it was setting the label, and then it was playing the voltage. And then I think I was testing the read resistance afterwards, and I put it. Well, okay, so what I was doing was updating the display every frame in the main loop. I was always updating the display in the main loop, and then only when you push the button, it was speaking. But it would also go ahead and update a reading. It would take a reading when you press the button as well. That way it wouldn't be showing something on the display that's different than what it said. We need to probably add smoothing. That's another thing I didn't do yet. I was just reading raw values and it's kind of jittery. But I think if we take like 10 samples and average them, I think it'll go a lot more clean. So we can kind of just do this similarly, but we'll do it when the screen gets touched instead. Then out here, we'll update the display. But I'm going to start with voltage instead of resistance. Okay. And then instead of setting up smoothing that was like legitimate and would have worked, I instead tried to like only change if it changed by enough. But I think we really want that right now. I'll do smoothing with an actual average instead of that. I think that's better. So get the voltage. Yeah, we'll set it. That's fine, but we're not actually using it. String val. Okay, so this should just start reading values and putting them on the display. Or crash. because I don't have the right arguments on get voltage takes in. Gonna log in. Okay, there we go. So that is just reading voltages. The pin is currently floating. So it's just undefined, I think. If I touch this, we could see it go to around 3.3 is the voltage that the microcontroller is running on, but it is still just floating right now, not like connected really. Okay, so now I think we want to scooch this one out a little bit. I can unplug this one, get this back, and it is time to start working with this mess. Let's get the DAC unhooked. So I bought one of those little puller things. It works super well. Little JST puller things. Small. I think these things are super nice, actually. But the problem is it's so small. I have no idea what I did with it. It's probably upstairs. This thing. These were super nice. I think I'm not positive, but I think Noe or Pedro, one of the two or perhaps both, worked on this. The design for this little JST puller. Like, I have relatively large hands for most of this little hobbyist stuff. JSTs in particular are kind of tough for me. This thing was super nice. I need to go find it and then put it in a dedicated spot. And my wish, actually, at some point, I hope there's one of those for stemma as well. I have a little trouble with stemma sometimes. Okay, so a lot of this is the DAC. I'm gonna try to unhook everything that is DAC related. And so now we have the analog is connected in the power, and conveniently white and red are the same colors as analog and power on the new. Let's get this out. Oh, can't do that. That's still connected. Ground from the button is on there. Let me get that. There we go. This feather can go out. Actually, let me put it over here. The speaker, I think, is out of here. I'm just going to get all of these off and basically take the whole DAC off of this breadboard because we don't need it anymore. But I'm gonna use the resistors on here. Well, not actually the literal ones that are here because they're small. I'm gonna put the ones that I got. Sorry, also, there's not much to see, but wiggle. Okay, what else do we have? This has a potentiometer knob here, which I was using for the voltage. So actually, I'll keep that. We'll wire that up in a minute. Okay. And I think I swapped the order of this at some point. But in my head, I think I like it the other way a bit more. So we have the two resistors. Right now, the way it's wired is power comes in from here, red wire. So if you were doing ohms, like resistor mode, you would plug the 3.3 wire. If I bring this one back into frame a little bit, you would plug the red wire from here into here. It would go through the first resistor. The analog pin would be connected between the two resistors, so that's this white wire here. That would be connected there, and then ground, the black wire coming out of here, would be connected on this end after the second resistor. And in the case of measuring resistors, you would want your first resistor here to be a known value, so like 10K for instance, and then your other resistor is your unknown one, and using the formula that's in the code, you can read the voltage and figure out the ohms of that second resistor. For measuring voltage, which is what I'm going to test first, instead of plugging in the microcontroller power to this red one here, what you would plug in is the voltage you want to measure. So in my case, the voltage I want to measure is going to come from this potentiometer, and the white wire is the voltage I want to measure. And I'm actually going to flow the other way, I think, because what I'm going to do is the mess of TLV DAC wires. That is one of the super duper nice things about this prop maker feather for this project is the whole DAC is already built in, so we just eliminated like 9 wires or something. A lot of wires, I don't remember exactly. So what I'm going to do is plug actually microcontroller power into my red rail on my breadboard. I'm going to plug power for the potentiometer into the red rail on my breadboard. So that potentiometer is now getting 3.3 volts in the red line there. The white one we want into the input. No, the white one we want into where we're going to measure, is over here. And then this green wire is jumping the two resistors together. Theoretically, we could have just put them on the same row, but I did it this way. So the white wire from the potentiometer, which is the one that will sweep, that one is where we want to measure. Power to the potentiometer, ground to the potentiometer, so that's all good. Nope, I'm doing this wrong. This is here. The white wire from the potentiometer needs to go into the first resistor. And then the pin where we measure needs to be here. And because, like, important to note, because I'm not using any volt, like right now the potentiometer's max is the microcontroller voltage, so I'm not at risk of like frying anything, I don't think, but I'm a software developer, not an electrician. I think that's the case, but you would want to be super careful if you were working with actual like 12 volts or something like that. You would want to make absolutely sure that your voltage divider was all set and correct, and you would want to make absolutely sure that you were plugging that 12 volts into the correct place in your voltage divider. I'm being a bit haphazard moving stuff around here, and in my case, I'm still working with small voltages, so we're not frying anything, luckily. I'm going to swap those around. They were just braided there. Okay, so there's this, and then ground would be at the far end. About me being haphazard there. And I actually just touched the ground into the power rail. Reset the microcontroller. So in fact, I'm just going to move the power to the other rail. That way you're off by 1. Okay, so ground we want connected at the end is basically, it's going to flow through this divider, right? Voltage is going to come in this case, white wire in through the first resistor. We're going to measure with this white wire here, and then voltage is going to keep flowing through the green wire, through the second resistor, and to the ground. So we come through that first resistor, and then down, and then back through the other resistor. Knock that. Super long red. I think my red. Anyway, I think I'm going to end up using a bit longer wires at some point as well. Okay, that I think is all good, but right now we have super tiny resistors. We could still use it to measure 3.3 volts, I think, but I'm going to go ahead and switch to resistors picked out. Told myself I was just going to keep track of which one was which, but I failed to do so. So I believe might be the NK. That is looking like brown, black, orange, gold. Oh, that's a... All right, 10K. That one is the 10K. That is what I want to use as the first resistor. And I should say, like, huge shout out, by the way. Hug reports are owed. Let me get this link, by the way. This was super helpful. That's right. This video is basically what made this click for me. This was I have sound on, which I normally don't, so that surprised me. But this person explains voltage dividers, how they work. He wires one up to a Raspberry Pi Pico, which is perfect because, like, I was trying to use it with a microcontroller. I was searching around online for information about voltage dividers. I was finding loads of it for the circuit itself, but less about specifically hook it up to a microcontroller and read from the parts of it that you're interested in. This person explained it also. Core Electronics, hug report to them on YouTube for that. And then the other thing is they also talk about this Falstead circuit simulator, which this is the first time I learned of this thing that I can recall. Although looking at the interface, it feels kind of familiar. Maybe I have seen it somewhere. But here you can actually do this. You can go get a voltage divider. It's actually more complex, has an extra set of them over there. You can do this, and then you can visualize what the electricity is actually doing here. So 10K resistor, just like I have, we can edit this one down to 3.3K, which is also what I have. This is like a measuring point, so that's where our analog pin is hooked up right now. And then this over here, you can set the voltage. So right now it's set at 10 volts in. We could change it to 12 volts in. And what we see is if we feed 12 volts in through our current voltage divider, through the voltage divider we have right now, sorry, not electrical current, but the one we have right now, if we feed that in, we're going to get 2.977 volts out in between them there, which is where, that's how I settled upon 10 and 3, is because I wanted to be able to measure 12 volts and below. we'll see how it works for 3 volts. I don't know if the range is going to be super good for 3 volts, but we'll see. We can adjust if needed. But yeah, shout out to this thing, Falstead Circuit Simulator, super cool. There's loads and loads of more built-in stuff. But even just being able to see this and visualize where this hooks up and what this circuit does was very, very, very helpful for my own understanding of it. Here, so this is the 10K one. I'm going to slot this in as the first resistor. Big's too wide. I used to have, I mean, I probably still do somewhere in this house, but I don't know where. I 3D printed at one point a resistor bender helper. In fact, I printed 2 because there were like big ones and small ones. It was like this little plastic widget that you could stick your resistor onto and then bend the legs perfectly. Okay. 10K goes there. 3K goes here. I believe this one is going to be the 3K one, but I also don't know, so we're going to double check on this thing, which is yellow, purple, red. So, gold, red, gold. Nope, this is the 4700. So that one was the one that I set aside to actually test the circuit. We can, in a little bit here, once we move on to resistance, we'll check that one and see if we actually calculate somewhere around 4.7. This one is orange, orange, red. This should be the 3.3K. Yeah, there we go. I didn't notice before, but on the left side of my breadboard, I have one lane in between each of the 2 resistors, but on the right side of my breadboard, I actually have 2 lanes in between. So this resistor is not straight across, it's actually diagonal by 1 lane. In any case, though, I think... Okay, so we're hooked up there. Got the analog, we've got power to the potentiometer, we've got grounds are all tied. Should be able to measure this potentiometer's voltage, I think. So if I turn it all the way one way, okay, unfortunately all the way, right now I'm all the way right and it's at 0.8. Go all the way left, we're gonna get down towards 0. Okay, so I think right now our range is not quite looking correct. Oh, also, I just noticed that it was on the screen, so about that, I can't take both of them. That's all the way to the right, and if I come down, play to the left, we get down to 0. So it sort of correlates, but it should be reading like 3.3 down to 0. I'm guessing I need to put the other resistor somewhere. Well, okay, I think we're not actually... So right now, get voltage, this is not accounting for the divider at all. When I did this circuit, The first time, I don't think I added the divider until I was testing the resistor, the read resistance thing here. We need this formula, but not this formula because this is resistors. We need this formula swapped around in some way. To get the right voltage. Yeah. Which, actually, speaking of this video, in fact, it's MicroPython, but I think that is good enough. There's code in this video. Okay, yeah, so we need both resistors. We need basically this formula here. My diagram implies a buffered voltage source. I'm not sure what that means, a buffered voltage source. Right now, the voltage source would be ultimately the 3.3 volt pin of the microcontroller, but it's run through the potentiometer. Okay, so let's rename these the same way, actually. I'm just going to do R1 10K, R2 3.3K. I did capitals because they're constants. It feels like they should be capitals to me. All right, so we have raw value already. Voltage. So we're already getting these two parts here. So raw voltage equals this. And then calculate the input voltage based on the divider rule. Vn equals... I'm probably going to change this to like voltage, like... I don't know. It's awkward to me that... because it calls this voltage out. And then it calls this voltage in. I guess kind of makes sense, sort of, but also feels backwards in a way. In any case, we'll match it for now. But mine is actually raw voltage, so we won't, because we're going to do that. So raw voltage times parentheses R1 plus R2 over R2. And then I'm actually going to call this measured voltage. Or calculated, in fact. Calculated. And return that. All right, theoretically now we should be able to get 0 to 3.3-ish. So I think currently it's all the way to the left, so we have 0.0, and then, you know, there we do see the wiggle action there because it's not perfect. But as I sweep it to the right, we work our way up to right around 3.3 volts. Yeah, that's what we're looking at. Okay, very good. That is exactly what we want. And that is still, I think, a fine range. I was worried a little bit if the resistors accounting for 12 volts was going to throw it off too far and make the 3 volt range a bit too steep or whatever, but I think it's actually pretty good. Let's do some smoothing. Potentiometer doesn't act like a variable power supply. It acts like two more resistors in a complex network with my two fixed resistors. Okay, I gotcha. That makes sense to me. Yeah, that's true. So, like measuring, for instance, we could measure a battery, as I understand it. Let me grab one, actually. I have... AA battery. It's a Li-ion AA battery though, which makes it a liar about its voltage because it's 1.2 volts instead of 1.5 volts like a regular AA. I don't know why the world, for some reason, we just like can tell that I'm not an electrologist because I don't understand why, but for some reason we just have AA batteries that are Li-ions that are the wrong voltage, and like some stuff works with it and some stuff doesn't, and like they just sell them that way, and I don't understand how or why, since I thought AA was like a standard. Anyway, doesn't matter. But I think we could measure the voltage on this. So let's think about this. So what we're going to be doing is we might need one more wire actually. So we want to replace the white wire here. Instead of our voltage coming from the potentiometer, we want it to come from the plus side of the battery. But we also still need to connect the ground side of the battery to the ground rail. One thing I don't have is, at least not handy, is a battery holder thing. We're going to do with this with the clammy hands holding wires onto it style and see if that works for us. Basically going to connect a ground, an extra ground here that I can touch to the battery, a red, because the red wire is longer, which I think is going to make this a little bit easier. And so we have 0 voltage or floating near 0 voltage. We could go ground on this side of the battery. There. And we can see 1.4 volts on that battery currently. So we're actually over the 1.2 that it says on the battery by a little bit. But again, our reading is imprecise. And obviously the smoothing, there's still no smoothing taking place there. So it's still quite jittery. Yeah, we can read direct voltage as well instead of the MCU voltage passing through extra resistance, or in this case, potentiometer. Sweet. Let's smooth it out some. For that, let's make a read buffer as a list. And what we're going to do is get the value, add it to the read buffer. If there's more than 10 things, we're going to get rid of the first one. So it's going to be a queue basically. They move from the back to the front, and then once they hit the front, they're going to get popped out. So if length of read buffer greater than 10, and we could play with that as well. Maybe bigger, smaller would make it better. I don't know. We'll see. If it's bigger than 10, we pop, get rid of the first one. So we should have like a rolling list of the last 10 readings. And then here we can get rid of this and we can put the average here. So can you do, is sum a thing? Sum iterable? Yeah, totally. So we could say, yeah, actually that's the code we want right there. Sum the last 10 values and then divide them by 10 or up to however many we've read. Technically, it'll be less than 10 the first few iterations, but then we'll be... That should hopefully smooth that out a bit, but doesn't really. I mean, we're getting quite a range right now, though. So, and right now, though, it is floating, in fact. So it is like legit, undefined, jumping around the expected, I would say. I'm just going to go back to the potentiometer for now because it's a bit easier. Ground into this rail, power into this rail, and sweeper into the input high side of voltage divider. Right now, that's all the way to the right. We can scale that down. Yeah, and I mean, it is still very, very, very jittery. Let's see if a larger buffer helps. I mean, kinda. Not exact. And one thing I can already tell, even at 50, it's now lagging behind quite a ways. It's like as I turn the knob, it takes it a while to catch up because it has to work its way through that entire buffer of 50. I think maybe 50 is far too many. We will stick with 10. And it does smooth it out a little bit, but there's still room for improvement. But I think that we may be sort of dealing with the nature of the beast as far as we have only a certain amount of ADC to work with. Okay. You know what I haven't tested is the touching. Let's actually do this the same though. Let's keep the buffer going here. So when you touch the screen, we'll take a new reading, we'll add it to the buffer, we'll cycle the front ones out of the buffer. Oh, I got rid of the new reading though. New readings, and then what on earth happened here? Okay, and then voltage. So when we touch the screen, it will read the current one, I think. Voltage depends on the chemistry. Leclanche cells, carbon zinc, heavy duty, and alkaline. One use are 1.5, then nickel metal hydride or whatever. Classic rechargeables are 1.2. Newer rechargeables copy one or the other. Yeah. I just don't like that. That makes some sense to me, but I guess I'm confused about like. It's odd to me they didn't keep looking for a different chemistry to get it to match 1.5 when they made that nickel metal hydride version 1. It's odd to me that they found a way to make it 1.2 and then just like went with it instead of trying to find a way to make it 1.5. But again, like I don't know anything about how they work under the hood. I'm probably grossly underestimating the challenge and just find one that works for 1.5. I do wish that all of my electronics worked with all of my batteries, is my main. After basic operation is nailed down, you may want to consider using Jepler's U decimal library instead of native floating point operations to maintain accuracy after averaging. Yeah, that's a good point. We could use udecimal, microdecimal instead of straight up math here, for better precision on, I think, like large floats and stuff, right? Or not large floats, but long amounts of decimals in the float. Yeah. Ask our chemist friends. Okay, so we should. I don't remember if I saved this. Let's rerun it just in case. And we should be able to play the current voltage as sounds. And now I don't know if I think I'm gonna. Well, let's try it. Okay, it did work, but it I have a sound noise gate on the microphone, and the microphone is directional as well, and it didn't play through there, I don't think. Let me fix this real fast. So I noticed it said something different than what was on the screen, which is specifically what I did not want. And what I did before that's why I was taking a reading here. So what we're gonna do is calculate the voltage, then do that. But before, we're actually gonna go and set it in the label as well. Here's this. We'll put it somewhere in the middle. And then what I'm gonna do is actually, I'll start it.
1.91.
Didn't really do it, but I'll play it again. I'm back here where you can actually hopefully hear it.
1.4036.
There we go. Okay, awesome. So that is all working perfectly. You got it all moved over from the old circuit. It is way less of a bird's nest of wires on a breadboard now. Losing the TLV helped a whole lot. The button eventually will be internal as well. Oh wait, no, I don't have a button. That's the potentiometer. I was using a button with these same sort of 3 wires. Okay. I think next I am going to, for just a little bit, I think I am going to work on the UI. So we have, oh, that's interesting, vaulted volume there. So I'm thinking for the UI, 2 buttons on the bottom. So like 1 button left half, 1 button right half. 2 buttons on the top. Again, 1 button left half, 1 button right half. And then I don't know which ones I want where just yet, but one of the sets of 2 are voltage mode button, resistor mode button. So you press 1 to go to voltage mode, you press the other to go to resistor mode. And then the other 2 buttons are resistor setters. So you press 1 button, it's going to take you to like a phone, like a 9-pad of numbers. You punch in the number of your first resistor, and then you press enter or something, and then there'll be a resistor 2 button. You press that, you get the 9-pad again, you punch in the number for your second resistor. And then it'll store those in the variables, R1 and R2, which will actually no longer be constants at that point. But then it will be able to do the rest of the math. And that way, when you provide your own resistors, first of all, if you don't happen to have 10K and 3.3K, but you have some others that'll work fine, you could just use those instead. But it will also, when you want to use resistor mode and you need to step down, like 10K and 3K might be too big, you know, you're not going to be able to measure like a 22 ohm resistor probably. And so in that case, you would need to step down maybe like 100 ohms and 30 ohms or whatever, right? You need a smaller scale set of resistors or Maybe not the raw values. Well, yeah, no, I think the raw values, but I'm not sure. Could hear it. Nice. Okay, cool. Okay, yeah. So I think 2 buttons top, 2 buttons bottom. The voltage stays in the middle, and then we have the second screen, which is the dial pad for typing in, like the 9 pad that lets you type in your value. And actually, we're on landscape mode here, so it might not be a traditional phone dial pad. I might do 4 rows of 3 or something. I think, or maybe even 5 rows of 3. It might be nice to have like 100, 1000 buttons to where for like a 3300, it'd be nice if you could press like 100 and then it gives you 3300. Or for 10K, it'd be nice if you could press 10 and then 1000. Instead of having to like punch in all those zeros. 2 in this case, but or 3. Okay, so we know we have 2 screens, right? We have the main screen that we're on now with the 4 buttons and the voltage readout. The second screen with the 9 pad. And so if I have multiple screens, always the first thing that I am reaching for in display IO land is the page layout. There's 2 oh no, I think these are, yeah, these, well, and one of them's me that I still have yet to circle back to. We're getting to the point where it doesn't matter too much, honestly, because it was about old versions of the way things worked. I want examples. I don't know why. Issues. Also don't know why that is just open. Yeah. Page layout. All right, so we can basically make 2 groups, 1 group for each page, and then, well, okay, so, and then what we're gonna do is, where did I make main group? All right, so main group is not gonna get the label put into it anymore. Instead, it's gonna get the page layout put into it. It's not the way that works. Page layout, it might not need X and Y. Those are the defaults anyway. I think we don't even need anything, honestly. We can just make the page layout. We can append the page layout to the main group because page layout extends group. It just is a group that hides and shows stuff, basically. Measuring resistance, your 2 resistors would be your reference resistor and the resistor under. Yeah, that's true. Yeah. So for measuring resistors, essentially you would take out the, what I have is the 3K. So the second one down here, you would take out that 3K or whatever you're using for your second resistor, and that's where you would stick your unknown resistor. So you'd have one known, the top one is known at, let's say, 10K, and then the bottom one is unknown. And then with the formula and the voltage you get from reading the pin, you can determine the ohms of that second one, that unknown one. Correct. Yep. And yeah, you need to use one that's from what I understand as well. You need to use one that's in the same scale, essentially the same range. You can't be like measuring a 22 ohm resistor with a 10K resistor. From what I understand, you need like 100 or, you know, you need something closer to the target one, which is why, like on the multimeter, it's got the dial, and you know it'll be like 2K ohms or 20K ohms or like 200 ohms or whatever. It's got those to where you kind of like start big and then scale down. All right, so page layout goes in the main group. We're gonna make a, it's weird to have a main group and a main page, but I kind of want to have a main page. Honestly, we don't need a main group, actually. We can just make the page layout, and then we could set the page layout as the root group. Yeah, I think. All right, so page layout, and then so we will go ahead and make a main page, which is a group, and we'll put our label in the main page. And and then we'll put the main page into the page layout. So page layout I think it's add content maybe. Yeah, add content. We give it the group, and then optionally we can give it a name, which I will go ahead and do. Content main page, and we will call that just main page. There we go. All right, so that should be enough to be able to still see the voltage. But it crashed instead, probably because I don't have the library. Could have just done up. Fine. Typing never hurt anyone. That's not true, actually. Repetitive stress injuries are real. Careful typing too much. Start this. Still crash. 4 arguments, 2 were given, 84. Okay, you have to pass X and Y? Is that for real? Hold on. We gotta take a brief detour because I'm a little flabbergasted about it. You have to pass X and Y. Strange. Those should just default to 0. Alright, let's do it. X 0, Y 0. I don't know what past him was thinking. I created the page layout at one point. I don't know what I was thinking, why I would think that should be necessary, but... Alright, there we go. Okay, so we're back to exactly what we had, but we are inside a page layout now, so we could add a second page as well. So to start with, I will just make a button... I might end up using custom buttons, but for now, I will just take a basic text button. It's kind of like has a billion things that are all set to variables, which I don't have, so we're going to fill in all of these things. So one of my buttons I want on the top of the screen, on the left half. So X and Y are going to basically be 0, 0. Width is going to be half the screen. I've already broke this out. 2. Height, I don't know. Guess something like that. Style, I want round rect. Fill color. So we're going to need to import button. We need to install that as well. That. Fill color. I don't know. Something, no, pinkish. Outline color. Say, not quite black, but dark. Label. I don't know if we can fit all of that in half the screen. We'll see. Button label color. We want to contrast. I think we can just make it the same as the outline. All right. Main page, append button. I'm actually just going to go ahead and change the name of this right now. Register 1 button. I like BTN for short there. Nope, crashed. It didn't install? I hadn't saved. Yeah. Crashed. Hagium layout doesn't exist. That's fair. There we go. It's kind of hard to see on the camera. I don't know if I have a sure that I have a super easy way to get that to focus better, honestly. Hmm. Okay. I'll stop jacking with the camera for now, but this is one of my first times using this new camera as well. So on the old thing that I had was like Android device, and it had a bunch of settings I could mess with. There's brightness and everything, and focus and some other stuff. This one is all automatic. It is a pink button though. Like physically looking at it with the naked eye, it's a pink button. It's just washed out because it's the brightest thing basically. I don't know. I'll have to figure out how to photograph it better at some point. But that worked. It did fit resistor 1 just fine. Maybe we could scale it, but I don't know that it has... Or that you can scale it or easily. We could scale the whole thing. Exactly what I want either. Scale just the text? Is that possible? Label scale or anything? I mean, we could cheat. There's self._label. I'm pretty sure you could do resistor button 1 underscore label. So like underscore should signify private, but Python, doesn't really have that concept. I think we could actually just do scale here and save this. And theoretically, we get bigger text. Yeah, but the problem is now it doesn't fit. And actually, it might fit, other than the fact that it's trying to center it. Yeah, okay, maybe I just need more light. So that was the other thing about the old camera setup. It was an Android phone. Therefore, there was a light right next to the camera. One of the controls I had was the ability to turn on and off the light. And thinking about it now, yeah, I was always turning on the light because it was allowing the camera to better see the screen, to flood the area with light. Maybe we need to figure out a way to mount a light onto this somehow. In any case, it did scale the text, but it's trying to center it, and the code that's trying to center it does not account for the fact that we just scaled it all willy-nilly, accessing its private thing, which is fair, right? We accessed its private thing. It didn't take into account what we did. That's kind of how it goes. Somewhere in here, though, there must be logic for trying to center it, and it would need to account for the scale in order to make that work successfully. But in any case, maybe I'll do that. Maybe I'll add that functionality to button as part of this project so that I can use it. It did work fine though, basically. So we got a resistor button. Let's undo the scale for now. A second one. Actually, before I copy it, not really need to. Own line. Colors together and then label stuff together. Okay. Let's do it. Mr. 2, 0, 0. So this time we don't want 0, 0. We want display width over 2 plus 1. And then, I mean, we could probably, might be nice to get a little bit more margin between them, but for now I'll stick with that. Same width. I'm actually gonna make it a little bit taller, maybe 40 pixels instead. I do want this to be ideally, hopefully doable with a finger instead of a stylus. It's a resistive touchscreen, so it's not like super duper precise. But I'm hoping that, you know, the 2 buttons on either half of the screen, I think that should be fine with a finger. The 9 pad will be dicey. We're gonna have to see if the 9 pad is actually feasible with a, you know, with your finger on a resistive pad. I think we should be able to get there because we've got, you know, the 2.4-inch diagonal, so we should be able to have like 1/2 inch or something for each button. Hopefully that's about enough, but made those taller. This one's gonna say resistor 2. I'll just leave it the same color for now. But eventually I think what I'll do is resistor buttons are one color, and then the voltage button and the ohms button are a different color. And those might even be different from each other. But the resistors can be basically both the same, I think. All right, so yeah, and again, I can't get the camera. I'm not gonna be able to get the camera to focus on the screen, but we've got resistor 1 button, resistor 2 button, all good. Yeah, I think I'm gonna leave it there for now. We've got about 10 minutes or so left. I usually stream about 2 hours. I don't want to go into making the... I don't want to get into making the 9 pad, because I'm definitely not going to have enough time to finish that up. So I think I will just stop here for now. I'll work on the other buttons later. We'll add the 2 buttons at the bottom, and we'll hook them up so that when you press them, they do whatever they're supposed to do. The resistor buttons will take you to the 9 pad page, wait for you to punch in the value of that resistor. The voltage button and the ohm button will switch a mode variable that takes you into whichever mode you want to be in. And then the resistor buttons, once you type in your number and enter, it will set these variables for it. Current, as in current measuring, maybe, but I don't know. I'm not planning on it right now. But maybe, I don't know. It will be probably, I would say, depends on what Lady Ada says, essentially. If she tells me to go and figure out the current and have it do that as well, then I definitely will. If she's good with voltage and ohms, then I will stick with that. It's basically up to her if she wants to spend more time on the project or not. Current was listed, though, in one of the possibilities in the idea, so there is some chance that I do end up current. I will say I have not researched that at all, so I don't know if it works with the same... I don't know if you measure current with a voltage divider also, or if you need a different kind of a thing going on there. So if I do get into measuring current, I'll need to read up on the actual, like, principles of it. But yeah, voltage and resistance for sure, and maybe on current. All right, I think I'm going to leave it there for now. Did pretty good. We got everything moved over to the new hardware. It's working, proof of concept. It can read the voltages. It can talk out loud. So that's the main 2 things it needs to do. We are well on the way with a UI. So yeah, I will keep working on this into next week. And then, yeah, guide should be out here in another week or so, hopefully. Hopefully I'll finish up the guide next week, and then it'll go through moderation and everything. I don't think I talked about this yet, so I'll mention this before I go away here. So everything is connected to the faceplate using these M2.5 nylon fasteners, which are just part of this set here. Thing right here. And so everything on the faceplate is connected with those. The feather wing, the speaker. Okay, not everything. The button is just a panel mount button. But what I decided to do for attaching the faceplate to the box is actually just have hexagon cutouts in these posts here. So in each of the 4 corners, there's a post and there's a hexagon cut out of it. And I'm just going to shove in one of these standoffs and a little dab of super glue. Just going to shove that thing in, super glue it in there, and then I can use those same exact 2.5 M2.5 screws to just screw that in. I don't recall ever seeing these nylon standoffs used as like threaded inserts before, but I thought it made a super nice way to connect it instead of using a traditional, like I have brass threaded inserts, which normally you would stick in with a soldering iron. You would heat it up and shove it in there, and then you'd be able to put a screw in it. But I don't have M2.5 ones, and I thought it'd be nice to keep everything at the same hardware size. So, thought that was a fairly clever way to do the screw. We'll see if it works. So I haven't done it yet. I don't know. Maybe the super glue is not going to work so well. I'm going to rough up the edges a little bit, I think, because they're very smooth. I'm going to rough it up a little bit, dab a super glue, shove it in there, and we'll see how that works. If it works good, then I may reuse that that threaded insert, those little standoffs. Current, okay, so C. Grover says in Discord, current would need a separate circuit based on a resistive shunt. Adafruit has some nice stemma modules for that. Thanks for the stream. Yeah, for sure. Thanks for following along. And yeah, I will sign off for now. So thanks to everyone for watching. I hope y'all have a good rest of your day and a good weekend, a good week. I will be back next week at the normal time, Saturdays, 10 a.m. Scott is doing deep dives, so if you didn't catch deep dive from yesterday, you can go back and watch that. I have not watched it yet, but I'm going to. I think he went over 2025 CircuitPython posts, and I need to still write my 2026 one as well. So yeah, deep dive is on Friday with Scott, and then I'll be back on Saturday next week at the normal time, 10 a.m. Central Time, here working on some CircuitPython stuff. And so long. Thanks for watching, and I will see you later.